Welcome to Team 47 Showcase. Today, we'll take you through the incredible journey of cross-platform framework that is being used for mobile application development. In recent years, humans became highly dependent on their mobile devices. It slowly started crawling into the fabrics of our life details. By now, mobiles are shaping the way we make history and express ourselves. Because each user has different needs, apps are developed to ensure demands are being satisfied. Looking into the history of mobile devices, and by that we mean commercially successful ones, not from the times of dinosaurs. In the 1990s, when a mobile phone became a necessity rather than a fashion statement, Nokia was the famous go-to company that by 2007 has dominated half of the market share, that is, before it loses that all. That was all pre the smartphone and touch devices. Phones in general were primitive in display size and process power. The result was simple applications that was developed for a specific platform. Games were one of the few applications that gave us developers the incentive to develop using a cross-platform technology. Java once gave us the promise of Aura, write once and run anywhere. The emergence of Apple with its first iPhone shaped a new era of mobile devices. Touch and bigger screen with some raw performance, and the introduction of the App Store meant business opportunities for developers. Yet Apple insisted that development must be done in a Mac environment using an old-age language. It is only when Android, the king of Androids, appeared that the game changed. That opened the door to 4 possible ways to develop an app. There was the traditional way of platform-specific tools such as Android SDK and iOS SDK, giving you a native application for one platform. And there is also a hybrid cross-platform such as Ionic that sacrificed native speed for cross-platform development. And finally, a native cross-platform frameworks that gave us the pros of both worlds, which we'll be talking about in this video.
Xamarin is a popular cross-platform technology where developers can build native user interfaces for iOS, Android, and Windows phones using a single codebase with C#. Xamarin was founded in 2011. By 2013, version 2.0 of Xamarin enabled native development in C# with either Visual Studio or Xamarin Studio. With only 200,000 developers in 2012, Xamarin gained popularity very quickly and crossed million developers mark in 2015. Xamarin's uptake by Microsoft in 2016 just further went to show that it was a well-accepted tool in the developers community. In addition to the significant cost savings, Xamarin's popularity comes from the fact that unlike enterprise solutions, Xamarin is natively compiled. Apps built using Xamarin contain standard native user interface controls. This results in apps not only looking the way the end user expects, but they behave that way too. On a Windows machine with Xamarin and Visual Studio, you directly build Windows and Android apps and run and debug them on the desktop devices or emulators. You can also remotely build, run and debug iOS apps via the Mac. The Mac with Xcode and Visual Studio for Mac installed serves as a build host, signing host and runtime environment for iOS apps. The applications run on an iOS simulator on the Mac or directly on a tethered device connected to the Mac. Hence, Xamarin can be used with ease both on Windows and Mac machines. Xamarin, along with providing support to existing developers, also offers certification courses for those who wish to learn. It also facilitates an online cloud testing lab consisting of more than 2,000 devices available for use in addition to local UI testing, which further imbibes the confidence in the developers. Xamarin is thus showing continued growth with version 3.0 already available for use, endorsed by a broadening showcase of successful applications, some of which have been shown above.
Our second showcase is on React Native, which is not a hybrid but also not your typical mobile OS native language, like Swift or Java. React Native allows the rendering of multi-platform user interface elements with just the maintenance of a single codebase, and at the same time retain the ability to further optimize for each platform by complementing the unified codebase with additional native code. React Native is based on React, which was first deployed by Facebook in 2011 and later by Instagram in 2012. Due to the shortcoming of existing platforms, engineers at Facebook decided to work on the preliminary concept of React Native as an internal hackathon project in 2013. In early 2015, React Native had its first public preview, followed by an official release in 2015 as an open source project. As its popularity rose and gained traction, React Native took over as the top development platform for both Android and iOS in 2016. So what is React Native? It is based on React, which is an open source JavaScript platform that was developed to facilitate web browser UI generation. React Native also uses JavaScript, except it facilitates UI generation using native mobile operating systems API calls. So the final product retains the look and performance of a native app, but at the same time can be easily ported to different mobile platforms without major code changes. At this point, we understand that React Native is very useful for apps that are expected to be running on multiple mobile platforms, as it minimizes the code changes needed, and if design allowed, all code can be maintained in JavaScript alone without touching on any Android or iOS specific languages. But other than this, it also has development-friendly features like hot reloading, which allows direct changes to source code even while the app is running, and have those changes reflected in real time back in the running app without the need for recompilation. Also, React Native allows mixture of native codes as well should there be need to provide further platform-specific features or optimization.
Now, let us look at some of the challenges with existing hybrid cross-platform frameworks. Vendor exclusivity to UX and low-level APIs are major factors when choosing hybrid platforms. Integration with the mobile hardware and firmware resources using third-party libraries is a challenge as well. Rendering HTML5 CSS contents on a mobile device consumes a lot of CPU and GPU, while a Swift written application is 3.9 times faster. Hybrid platforms do not have direct access to GPU and has low computational performance when compared to native. In general, hybrid applications have poor user experience as compared to the applications developed using native framework. So, how can hybrid cross-platform frameworks sustain its attractiveness against native? With shorter SDK release cycles, it can offer almost same features, stability, and security as native SDKs almost immediately to the application developers. Having close collaboration with vendors and development community, hybrid platforms can leverage the same level of access to the resources as native and offer more features. By offering application templates and customization capabilities can make the hybrid platform more attractive to the consumers. Offering rich feature libraries, it can lead the way in providing better or equally good user experience. Hybrid platform can also look forward to integrating with AI and voice assistant capabilities. With ever-increasing market for both mobile devices as well as applications, continuous research and development of hybrid cross-platforms application framework is the way forward. On behalf of our team, Aman, Kriti, Joyan and Abhishek, thank you.